Okay, we're going to go ahead and go over the review for ratio, proportion, and similarity and geometry, which is coming up very soon for your test. And so we'll start with the very first problem. This is asking us to solve proportions to begin with. So when we solve these proportions, we are going to do what's called the cross product. So we're going to multiply like this. 24 times x is 24x. And then we will use probably the calculator here to do 16 times 36, which is 576. And then we'll divide both sides by 24. Okay, and then 576 divided by 24 is 24. So x equals 24 is the correct answer. All right, let's take a look at now number two. Number two, we're going to cross multiply. So we get 3 times x is 3x, and then 4 times 39 is 39 times 4, and my calculator gives me 156. Okay, and now we will divide both sides by 3. And 156 divided by 3 is 52. So x equals 52 is the correct answer on that one. All right, so now I'm going to move on to number 3. In problem number 3, we this time do have a little bit difference here where we have a plus sign. So anytime you have a plus sign, you are going to need to use parentheses around that. So 2 times x plus 12 equals 5 times x is just 5x. And now we'll distribute. So 2 times x is 2x. 2 times 12 is 24. We do want the variable to be on one side. You can move the 5x to the left if you want, but I think it would actually be better to move the 2x to the right in this case. We're running out of room, so I'm going to go back over here like this. And so we have 24 equals 5x minus 2x is 3x. And then we divide by 3. 24 divided by 3 is 8. So x equals 8 is the correct answer to that problem. All right, let's take a look at now number 20 or number 4. This one's a little bit more challenging. We have x times x, which is x squared, and then 8 times 32. So again, I'm going to use my calculator to see what that is. So 32 times 8 is 256. Now, to get rid of the square on the x, we have to take the square root of that. So technically, we would, in a quadratic equation, that means to the second power, you do plus or minus with that. Now, in most of our geometry problems, we're not going to have a negative answer, but this is not strictly a geometry problem here. So I'm going to have two answers for that. So the square root of 256, we'll definitely have to use our square root key on this. And we get 16. So positive or negative. 16 is the correct answer to number 4. All right, let's continue on now. Now we'll get into more of the geometry problems. It says for problems 5 and 6, find the measure of the angles of the triangle with the given extended ratios. Draw your picture, label your angles, and set up the equation and solve. So if the ratio of the angles is 1 to 2 to 3, then it's like the three angles are 1x. I'm sorry, I keep hitting the camera here. 2x, excuse me, 3x. So that is how we set this up. Well, I can see you can't see that there. Let's do that. I'm going to zoom just out a little bit because I'm going way too far. And of course, now my camera is a little blurred. So let me see if I can't refocus the camera there. All right, here we go. So we know that the three angles of a triangle have to add up to 180. So my equation would be 1x plus 2x plus 3x equals 180. So these are all like terms. 1x plus 2x plus 3x is 6x. Now we're going to divide both sides by 6. 180 divided by 6 is 30. And it did say set up the equation and solve. And then in the directions, it did say find the measures of the angles. Find the measures of the angles. So this smaller angle is like your 1x. So 1x would be 30 degrees. Your 2x would be 2 times 30, which is 60 degrees. And then your 3x would be 3 times 30, which is 90 degrees. So the three angles, 30, 60, and 90, are the correct answers to that problem. All right, on number 6, we have 4, 6, and 8 is our ratio. So the smaller angle is 4x. The next smaller, it would be 6x, and then we have 8x. Okay, so my equation is going to be 4x plus 6x plus 8x equals 180. These are all like terms, so 4x plus 6x plus 8x is 18x. And then we're going to divide both sides by 18, and then we get x equals 10. So our three angles, our 4x would be 4 times 10, which is 40 degrees. And then our 6x, that would be 6 times 10, which is 60 degrees. And then 8x, 8 times 10, is 80 degrees. And you should notice that the three angles do add up to 180, and that's the case. And I'll just go back a little bit. On the last problem, those three angles, 30, 60, and 90, they all add up to 180 as well. So that's a way you can check in the end to see if you're right, if your three angles add up to 180. All right, so now we're going to take a look at number 7, and it says determine if the polygons are similar. So in order to determine if the polygons are similar, we have to have some things going on. Now, the first thing we have on this one, we have triangles. Now, there are some, for triangles in particular, we have 3 rules that we can apply, little shortcuts: angle, angle similarity, side, side, side similarity, or side angle, side similarity. Now, these 2 triangles do not have any side measures given. So the only way we could prove that those 2 triangles are similar is through angle, angle similarity. So I'm going to have to find the missing angles, because right now I only have a common 40. So let's look at this one: 80, 40, and what? Well, remember the 3 angles add up to 180. So I'm going to do 80 plus 40 is 120. And then 180 minus 120 is 60. So this angle is 60. I could do the same thing for this one if I wanted to, but I don't really have to. I have a 60 and a 60, and I have a 40 and a 40. So these 2 angles are, or these 2 triangles are similar, and that's because of the angle-angle similarity theorem. All right, let's take a look at now number 8. Number 8, we have rectangles. So we do know, because of the fact that these are rectangles, we're going to have 4 right angles in each of the rectangles. So I'm going to go ahead and label that. So all the corresponding angles are going to be congruent, which is one of the requirements for any other figure to be similar to each other. And then we need to do the ratio of the sides. Now, if this is 3, this has to be 3 for a rectangle. If this is 4, this has to be 4. Same thing on this one. This is going to have to be 5, and this is going to have to be 6. So what I have to do is I have to do the ratio of the corresponding sides. The smaller side is 3 on this one. The smaller side on the other one is 5. And that needs to equal the ratio of the larger sides, 4/6. Well, 3/5 is 0.6 as a decimal. 4/6, 4 divided by 6 is 0.66666. So these are not equal. These are not equal. So this is no. Even though the corresponding angles are equal to each other, the ratio of the corresponding sides are not equal to each other. So we cannot say that these two rectangles are similar to each other. All right, it says on numbers 9 and 10 to find the scale factor of the similar polygons. So I'm assuming this is they didn't really tell us this, and they really should have done so, quite frankly. Um, so I'm going to let's go ahead and add this to the figure. And again, all of the angles, we're going to say this is a regular pentagon. It kind of looks like a regular pentagon. They didn't really do the markings as they needed to, but that's fine. We'll go ahead and add them now. So let's assume that all of this that I just put on the figure was given, even though it wasn't. So I already have the corresponding angles are congruent to each other. And now what we have to do is just say, what is the scale factor? Well, the scale factor, if we're going large to small, that would be 7 to 4. If we were doing small to large, that would be 4 to 7. So it depends on how the question is worded. They didn't really very specifically say large to small or small to large. So it depends on your test. They will be more clear on that. All right, let's take a look at number 10. Okay, number 10 again. They really, well, we don't need angle measures on this one. So what we need to do is we need to match out the corresponding sides, the smallest to the smallest. So this would be 3 to, it looks like 6, sorry. And put 8, but nope, it's 3 to 6. And then 4 matches with 8. And then 5 matches with 10. And if you use your calculator and simplify these fractions, this is 1/2, this is 1/2, and this is 1/2. So the scale factor, if we go large to small, that would be 2 to 1. If it's small to large, that would be 1 to 2. Okay. So those are your scale factors. Let's take a look at now number 11. Okay, number 11, find the length of the missing side. So we are assuming that these are similar. They didn't really say they were, but we'll assume that they are similar. So we got to match up. The smaller sides are X and 4, and then the larger sides are 12 and 8 for these rectangles is what they look like. So I'm going to cross multiply. X times 8 is 8x. 12 times 4 is 48. Divide by 8. 48 divided by 8 is 6. So x is equal to 6. Okay, they're telling you in number 12 that the scale factor is 3 to 7. So we're assuming because this looks smaller and this larger, we would do 3 over 7 equals 21 over y. Cross multiply, 3y equals 147. Divide by 3. 147 divided by 3 is 49. All right. Let's take a look at now number 13. Okay, they want to know, are these similar? And if so, why? So, first of all, we do have a congruent pair of angles, and then in between two given sides. So now what we need to do is we need to see is the smaller one to the smaller one equal to the larger one to the larger one. Okay. And it looks like 3 over 6 is 1/2, 4 over 8 is 1/2. So this is yes. And the reason is side angle side similarity. Side angle side similarity. Okay, let's look at number 14. Now, notice that they do have arrows on this. So that means that these are parallel to each other. So what we have here is we have some alternate interior angles that are congruent. We also have another pair of alternate interior angles congruent. We could even say that these vertical angles are congruent. So the fact that they give you an 8 and a 9 is completely irrelevant because I don't know anything else about the measurements. I don't know anything about these two sides or these two sides. So that's not going to do me much good here. But what I do know is, yes, these two triangles are similar because the three angles of this triangle are congruent to the three angles of this triangle. So this is yes, we only need two. So angle similarity is the reason. Okay, let's look at now number 15. Number 15, if it's going to be anything, it's going to be side, 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 because we don't know anything about the angles. But what we have to do is we have to match small to small, medium to medium, and large to large. Okay. Well, unfortunately, this is 4, this is 5, and this is 3. So this is a no. They are not similar because even though it looks like side, side, side similarity, it is not because the ratios are not the same. All right, let's take a look at now number 16. Number 16, again, I do see some parallels here. So that means that this angle is congruent to this angle by the corresponding angle theorem. This angle is congruent to this angle, again, by the corresponding angle theorem. And on top of that, they share this angle in common. So that's like the reflexive property. So what we're going to have to do is we're going to have to look at two similar triangles. We have the small triangle up here. This is 3 and 5. And then we have the larger triangle. Now you got to be careful with this. It's not 8, it's 3 plus 8, which is 11. And it's not x, it's 5 plus x. So that's how I'm going to have to use, I'm going to have to use these two triangles that we know they share that angle in common. We know that these triangles are congruent to one another, are not congruent, but similar to one another. So our proportion is going to be that 3 corresponds to 11 and 5 corresponds to 5 plus x. So now we're going to cross multiply 3 times 5 plus x equals 11 times 5. I'm going to distribute the 3. I'm going to come over here. 3 times 5 is 15. 3 times x is 3x equals 55. I'm going to subtract 15 from both sides, so I get 40. And then I'm going to divide both sides by 3, and I get 40 thirds, which is about 13 and 1/3 or 13.33333 forever. So you can make it 40 thirds, you can make it 13.3 repeating, or you can even make it 13 and 1/3 like that. Any of those answers would be acceptable. All right, let's take a look at number 17, a little bit more complicated. When they have the base here, that's when you really have to watch carefully. I do know these two angles are congruent to each other because they're corresponding and these are parallel. Same thing here. And then, of course, they share this angle in common. So if I redraw the triangles, this is what I have. I have a 6 and an 8 right here. And be really careful right here. It's not 2, it's 6 plus 2, which is 8. And then the x is right here. So 6 goes with 8, and 8 goes with x like that. Left, left, base, base. That's how I write my proportion. Cross multiply, and we get 6x equals 8 times 8 is 64. We're going to divide by 6. Unfortunately, it does not divide evenly by 6. 64 over 6 does simplify to 32 over 3. That would be 10.666666 forever, or 10 and 2/3. You could also leave it 32 thirds. So again, you could write it like this if you want, or you could write it 10 and 2/3. All of those answers are acceptable. Okay. Number 18, again, we have parallel markings. So this angle is congruent to this angle by the corresponding angle theorem. This angle is congruent to this angle by the corresponding angle theorem. And on top of that, they share a common angle. So let's look at this one. I'm going to draw two similar triangles. So here's the smaller one first, this little one right here. This is X and this is 9. And then here is the larger triangle, X plus 4. And then this is going to be 12 over here. So here are the two triangles that we're working with. So X goes with X plus 4. And then the 9 goes with the 12. This is how we have to set it up. So we're going to cross multiply 12 times X. And then 9 times X plus 4. We do need parentheses for this because there's a plus sign. Distribute. So 12x equals 9x plus 36. We're going to subtract 9x on both sides. Running out of room, so I'm going to go over here now. So 3x equals 36. Divide by 3. 36 divided by 3 is 12. Okay. All right. So number 19 and 20, we have problems involving an angle bisector. So while the angle bisector does not, this angle right here would be congruent to this angle right here. It does not create similar triangles. It does create a proportional relationship. So you could say 5 over 4 equals 7 over x. That's one way. You could also do this. You could do 5 over 7, sorry, left over right equals left over right as well. So either way, when you cross multiply, you get 5x equals 28, you get 5x equals 28. It doesn't really matter which one you want to use, but because you get the same cross product. Then I'm going to divide by 5. So 28 over 5 could be an answer. You could also divide it and getting a decimal, so that would be 5.6. You could also, put it in your calculator, 28 fraction key 5, and that would give you 5 3/5. So any of those answers would be acceptable answers. All right, let's take a look at number 20, somewhat of a similar problem, except no, nothing special about that. So here it is, this one right here. So again, I could do 8 over 12 equals 6 over x, or I could go 8 over 6 equals 12 over x. It really doesn't matter. So I'm going to do 8 over 12 left over right equals left over right, like that. Cross multiply, we get 8x equals 72, divide by 8. 72 divided by 8 is 9. All right. So that's the answer for that one. All the directions said was just to find x, so that we can stop right there. All right, number 21. So number 21, I have parallel lines here. So if this is 50, this is 50. And if this is 70, these are vertical, so this is 70. So now I just have to, I have a triangle where I have 2 out of the 3 angles, the third angle theorem, or excuse me, the triangle sum theorem. Let's get that right. 50 plus 70 is 120. And so 180 minus 120 is 60. So the answer to number 21 is x equals 60. Okay, let's take a look at now. Third page of the review, we have what's called extra review. Okay, so let's see. Question number 1 says, determine if the following triangles are similar. So if you're having a missing angle on a triangle and you 2 out of the 3, you definitely want to do the triangle sum to see if the missing angles help out here. So I'm going to add them. That's 108 on this one right here. 180 minus 108 is 72. And so I have a 90-degree angle and a 90-degree angle. I have an 18-degree, whoops, this would have to be 18, but I have a 72 and a 72. Let me erase that right here. a 72 and a 72. So this is, yes, they are similar by angle similarity. So if two angles of one triangle are congruent to two angles of another triangle, they are similar by angle similarity. Let's look at number two. Okay, number two. So I do have two triangles in this picture. Actually, I have three triangles in this picture. So let's see here. Let's start with the two smaller ones here, and we're going to match up small with small, medium with medium, and large with large. So if I do small with small, that's 8. Small and this one is 8. The small and this one is 8. The medium in this one is 18. The medium in this one is 10. And the large in this one is 20. And the large in this one is 10. So this is not true. So this one is not similar to this one, but we do need to look at like the medium triangle and I mean this triangle right here and the over large triangle right here. So the small side is 8. And then remember, this whole thing is the big side. 20 plus 15 is 35. So 8 is the small one on this little triangle. 10 is the small one on this triangle. And then in this triangle, the 10 is the medium one. And in the big triangle, 18 is the medium one. And then this small triangle right here, 15 is the large side. And then 35 is the large side. Well, 8 over 10 reduces to 4/5, but 10 over 18 reduces to 5/9, and 15 over 35 reduces to 3/7. So this is not true either. All right, now we're going to compare this triangle right here with the over large triangle. So in this triangle, the small side is 8. In the over large triangle, it's 10. The medium size is 18. Okay. Before I go any further, let me go back. I just realized I messed this up. It's not 18 here. So 8 in the small triangle goes with 10. Okay. In the big triangle. Medium size 10. Okay, that's actually right. I'm sorry. All right, we'll go back to this now. 8 is small. In the big triangle, 10 is the small. The medium size in this triangle is 18. And then in the large triangle, it's 18. And then in this triangle right here, the largest size is 20. In the big triangle, the largest size is 35. Well, 8 over 10 reduces to 4/5, but 18 over 18 reduces to 1. And 20 over 35 reduces to 4/7. So no, there are no similar triangles by side similarity on this one. All right, let's take a look at number 3. Okay, first of all, we do have some vertical angles. So I don't know anything about these sides. I don't know anything about these angles right here. So the next thing we would do is see if the sides that are given to us are proportional. Now, 9 is the smaller one here, it's 15. So don't go 9/20. 9 matches with 15. 12 matches with 20. 9/15 reduces to 3/5. 12/20 also reduces to 3/5. These both equal 3/5. This is true. That's true. So we have the answer to this one is yes by side angle side similarity. Continuing on to number 4. Okay. This one, if it's going to be anything, it's going to be side, side, side. So we have to match small with small, large with large. And of course, the other ones are the same because this is an isosceles. These are both isosceles. 16 over 4 is 4. 28 over 7 is 4. 28 over 7 is 4. This is true. So this is a yes. And the reason is side, side, side similarity. Okay, let's take a look at number 5 through 7. We're referring to this figure right here. We do not know. We have a little problem. They really should have said this, to be brutally honest with you. and that is that we're going to say that these are they parallel? We're hoping, I'm sorry, we don't, well, if they're asking you to make, yeah, they really should have said this. I'm sorry. They should have said this. These are parallel because you can't write any proportions if you don't know the lines are parallel. All right, so AC, and then over here we have DF. So it'd have to be AC over CE equals BD over DF. Okay. So if I fill in the numbers with this one, it would be X over 12 equals 5 over 15, like that. So we're going to solve for X. 15X equals 12 times 5 is 60. 60 divided by, whoops, you can't see that. 60 divided by 15 is 4. Okay. Let's take a look at number 7. What is the scale factor? Now you got to be really careful with this because the scale factor is not, you don't do like 5 over 15, 4 over 12 necessarily. Okay. What you have to do is like this is from 5 to 15, 5 to 20. Okay. And then over here, it will be, well, you can't see that. I'm sorry. This is 5 to the whole thing is 20. This is, we already said this is 4, so the whole thing is 16. So you could also do 4 over 16. So the scale factor is 1 to 4 for the triangle, or not really the triangle, it's just the figure. Okay, let's take a look at number 8. Okay, number 8. You can do this over this equals this over this if you want. You can also do like two similar triangles. So like this could be 18 and 15 for the small triangle, and then you have this larger triangle. This would be 18 plus x and then 20. So you could do 18 over 18 plus x equals 15 over 20, and that works. That works. This, in fact, works all the time. Now, it is true that when these lines are parallel, and again, they did not really say this, and they really should, to be brutally honest with you. They should have said that. They didn't. But you could also do 18 over x equals 15 over 5. I caution you about doing something like this because this works fine on the left sides and the right sides. But if you're looking for this and this, you do need to do this drawing two separate triangles. But you don't have to do that on this particular problem if you don't want to. I'm going to go ahead and use these. So 18 over 18 plus x, and then 15 over 20. Okay, cross multiply. So you're going to do 15 times 18 plus x equals 18 times 20 is 360. So we're going to go ahead and distribute 15 times 18 is 270. This is going to be plus 15x equals 360. Okay, then we're going to subtract 270. So 15x equals 90. And then we're going to divide by 15. So x equals 6. All right, on number 9, it really should say is segment BC parallel to segment DE. So the way we would do that is you could do like we did in the last one. So this whole thing is 25 and this whole thing is 20. So is 18 over 25 equal to 15 over 20? You could also do is 18 over 7 equal to 15 over 5. Either one would work on this one. Again, I caution you very carefully. It is true you can do this only when you're doing left sides and right sides. If you start having the base, you really do have to do the whole thing. So if you do, you could cross multiply if you want, or you could turn these into decimals. It really doesn't matter. If I turn 18 over 25 into a decimal, this is 0.72, and then 15 over 20 is 0.75. So this is no, because the ratios are not equal to each other. So these lines are only parallel when these ratios are equal. And number 10, it says to find the distance from A to C, this one right here. So number 10 is where this is, they didn't say this, and they really should do this. Like, this is an angle bisector. They left that out, and they really need to do that. Okay, so let's take a look at, we're going to call this X, because I don't know. So you could do like left, you could do X over 7 equals 27 over 21. You could also do X over 27 equals 7 over 21. Either one would be fine. So 21 times X is 21X. And then 7 times 27 is 189. All right, so 189 divided by 21 is 9. So your answer to A to C is 9. All right, last thing, we have some word problems on this test. So here are some very similar word problems that you will see on the upcoming test using similar figures and proportions. All right, so number 1, it says the ratio of dogs to cats in an animal kennel is 9 to 5. If there are 27 dogs in the animal kennel, how many cats are there? So it did say dogs to cats. So I'm going to go ahead and do like D over C just to help myself. So the ratio of dogs to cats is 9 to 5. We know there are 27 dogs, and I don't know how many cats. So I'm going to use C for cats. So now I'm going to cross multiply 9 times C, and then 27 times 5 is 135. Divide by 9. So 135 divided by 9 is 15. So there are 15 cats in the animal kennel. Okay, let's take a look at now number 2. Number 2, it says a flagpole casts a flagpole that is 30 feet tall casts a shadow of 20 feet. At the same time, Guillermo casts a shadow of 4 feet. How tall is Guillermo? So I have a flagpole. Here's my flag. I don't, it's 30 feet tall. And then here's the shadow. The shadow is 20 feet. Then over here we have Guillermo. He is, I don't know how many feet tall he is, but his shadow is 4 feet, like that. So what we're going to do is we're going to do the height of the flagpole over the height of Guillermo, which we don't know. The shadow of the flagpole over the shadow of Guillermo. So now I'm going to cross multiply. 20 times x is 20x. 30 times 4 is 120. Divide by 20. 120 divided by 20 is 6. So Guillermo is 6 feet tall. Okay. Let's take a look at number 3. It says a photo is 4 inches wide and 6 inches tall. It is enlarged so that it is 10 inches wide. How tall is the photo? So here's the original photo. 4 inches wide, 6 inches tall, like that. We're enlarging the photo. This. A little too big there. It's 10 inches wide, and I don't really know how tall the new photo is going to be. So height over height equals width over width, like that. 4 times x is 4x. 6 times 10 is 60. Divide by 4. 60 divided by 4 is 15. So the photo is 15 inches tall. All right, let me zoom out just so you can see this a little more clearly. All right, that last one, let me go ahead and also focus that just a little bit better now, hopefully. There we go. Okay, it says a mirror, here's my mirror, is placed between a tree, and here's Annalise. The distance between Annalise and her eyes is 5 feet. So like kind of like that, 5.25 feet. Okay, and then the mirror is 20 feet from the base of the tree. Here's the 20 feet right there. And then Annalise is 21 feet from the mirror. And we want to know how tall is the tree. Okay. All right, so here we go. So we're going to do, I don't know how tall the tree is. I know Annalise is 5.25 feet. And then the tree is 20 feet from the mirror. And Annalise is 21 feet from the mirror. So this is not going to be a very tall tree. So we're going to cross multiply. 21x equals 20 times 5.25 is 105 divided by 21, and we get 5. So the tree is 5 feet tall. All right. All right, that concludes the review in geometry for this test, upcoming test. Hopefully you worked on all the problems yourself first, and then you used this video just to check the answers, and you were paying attention to the mistakes you might have made, and so that you don't make those same mistakes again on the coming test. Good luck on the coming test.